to be going over, right triangle trigonometry. Woohoo! Gonna be some fun, guys. But seriously, it is gonna be fun. Trust me. When you know how many trigonometric or just trigonometry applications there are in the real world, you're probably gonna be shocked. But let's save that for another video. So before we start, of course, I would just, what does the term right mean? I just want you guys to just sort of think before we get into it, either mathematically or in real life. What does the term triangle mean? Maybe think mathematically, real life as well, and trigonometry as well. Even in real life, what is trigonometry? What is it in real life, and what is it, of course, mathematically? So and then, of course, what does a right triangle mean? Both mathematically and in real life. What does maybe right triangle sort of, we interconnect all of them, right triangle trigonometry? What does that mean in real life and in mathematics? So that's what I sort of want you to think as you watch this video and as we study right triangle trigonometry. Of course, this video is going to be sort of a review rather than teaching you it, because you should know at least the basics of trig, hopefully. Anyways, moving on. Let me just get this out of the way here. Anyways, let's get into it. So, let's say we had some triangle. Okay? Try my best to draw a triangle here. And it's given to us that it is a right triangle, right? Because we're studying right triangle trigonometry. So it's given to us that it is a right triangle. Now, let's say we had some unknown sort of angle measurement here. Okay, let's say here. And we can denote that as theta. And if you guys remember theta, right, represents an unknown angle measurement either in degrees or radians. And we'll talk about radians in another video, but hopefully degrees, at least degrees sounds familiar to you. We'll talk about radians in another video. So theta, you can think of it as like a variable as well, right? Like variable. And we can also just say, like, for example, if we have x, that could also represent an unknown angle measurement as well. So something to keep in mind, that is, of course, just remembering what do these symbols mean. And of course there are Greek symbols as well that are also used in trigonometry, but usually the common one is either theta or like x or y or something like that, either a variable or just theta itself. So we have an unknown angle, we know that is theta. Now let's just define some key terms here. So let's say let's just call this triangle, let's call it ABC. Okay, ABC. Sounds familiar, right? Pythagorean theorem. But we're not going to go into that today, but you will need the Pythagorean theorem in some cases. In fact, we actually may need to use it today. So, anyways, let's define some sort of things here. Let's say we have theta. Now, what if the question asks us, let me use a different color here. Like, question asks us, like this question, like, what is opposite to theta? To theta, opposite to theta. So, what is opposite to theta? Well, let's just draw an arrow. We see that A is opposite to theta, right? So we can just say A, right? Now, another question that could be asked. Let me just see here. Can I remove it? Please, can I remove it? Or you want, let me just erase it. Why not? Okay, so let me just rewrite our answer here. We answered right, A. What is opposite to theta? A is opposite to theta. Right, how did we do that? We drew an arrow. And right, A was to just prove, right? What is opposite to theta? A is literally opposite to theta. Now, another question what is adjacent to theta? To theta. Well, what does the term adjacent mean? Now, hopefully you should know this. Adjacent literally just means what is like next to, right? Next to. Next to. So, what is next to theta? Well, we can again draw sort of like an arrow. Well, we can see here what is next to theta. B is next to theta, right? So we can say B, right? We can just say B, right? Because adjacent, if adjacent means next to, then B, isn't that B next to theta? Isn't it? So, final question is, what is the hypotenuse? So, also let me write a question mark here, just wondering, because question mark indicates that it is a question. So what is the hypotenuse? Now, using your knowledge, maybe geometry and the Pythagorean theorem, the hypotenuse is, well, first of all, known as the longest side. Let me draw the arrow here. Longest side of right triangle. Of right triangle, and also the hypotenuse is just opposite the right angle. So it's literally just opposite the right angle. So what do I mean by that? Again, like, how do we find what was opposite to theta? We drew an arrow, and literally what was opposite to it was A. Same thing. What is opposite to a right angle? C is opposite to a right angle, right? So in this case, let's see here, can I do this sort of box removal thingy? I'm just gonna use the eraser, do it old school. So the hypotenuse will be C, right? Because if, one moment, what is happening? Okay, so our hypotenuse is C. Well, why? Because what is opposite to a right angle, right? Opposite right angle. The hypotenuse is opposite our right angle. Well, opposite a right angle. How do we determine what is opposite a right angle? Just draw an arrow, right? We have a person here, and we have a person here. Just draw an arrow. This person is opposite to this person, or vice versa. This person is opposite to this person. Literally, use sort of logic here. Okay, so now sort of getting like what is opposite to theta, what is adjacent to theta, what is the hypotenuse. You're probably like, why am I asking these questions? Well, hopefully you know what I'm about to ask, or what I'm about to explain right now. If you, because once again, this is sort of a review, uh, unless you're just a fast learner, and you can probably just get sort of the tone or like what I'm about to do. So, what if I now I'm going to explain something. So now that we identified, let's just quick recap here. Opposite side, I'm just going to write OPP that equals that, well, opposite side to theta, that literally means opposite to theta, that is A. And we can write adjacent here, right? Adjacent, we can write that as like ADJ, that equals to B, right? Adjacent to to theta, right? Next to is B. And of course our hypotenuse, we can write that as HYP, that equals to C, right? So now I'm going to explain something, our trig functions, okay? Trigonometric functions. So, or ratios perhaps. So by definition, sine of theta equals to opposite over hypotenuse. Opposite over hypotenuse. Now in this case, remember opposite of theta is A, and our hypotenuse is C, because C is opposite the 90-degree angle, or the right angle. So in this case, right, sine of theta would equal to A over C, right? Because opposite over hypotenuse by definition. Now, what about cosine of theta? Well, cosine of theta, that equals to adjacent over hypotenuse. And using our triangle here, how can we find that? Well, remember, what is adjacent to B, right? Or adjacent to theta. B is adjacent to theta, right? Because it's next to, right? So B, so cosine of theta equals to B, and then over our hypotenuse across opposite the 90-degree angle, or the right angle, is C. So B over C. Right? So A over C is for sine, B over C is for cosine. Now, finally, we have tan, or tangent. What are you going to call it? Like, you can write this as, people just say sine here. This is represented as sine. Some people say cos. This is cosine. Some people say tan, but full name is tangent, etc. So now, tan is the only one that just doesn't involve our hypotenuse here. It is actually opposite over adjacent. So this is the only one that does not involve our hypotenuse, right? Our hypotenuse is only involved in sine of theta and cosine of theta. So now tangent, or tan of theta, is opposite over adjacent. So remember, opposite of theta is A, right? Or let me first get a green ink here. So tan of theta, remember, opposite over adjacent, right? So tan of theta, right? So A is opposite, remember, over our adjacent side, which is b, right? B is next to theta. A over b, right? Now, hint, we already defined these, right? But I'm just still going over it. Why is it adjacent? Why is it opposite? Why is this the hypotenuse? Etc. So, using these trig ratios, we could figure out what was sine of theta using the triangle that we had constructed. Anyways, this is the basics of right triangle trig, but now we're gonna sort of get, you know, more, into it. And, just one thing to note here is that there is a sort of a way to memorize these. If you are, like, oh, do I remember sine is opposite or hypotenuse? Like, that's not the way I want to remember it in my head. Well, another way is just so katoa. Maybe you've heard of this. So, right? So, sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So, this is common way of memorizing the the generic trig ratios. Now, we're going to talk about something which is little more, ahead of the game here. Let's just say that. And what? Well, not really. If you understand this, you are able to understand what I'm going to talk about next. So, I am going to. No, that won't work. I am going to. Let's just say. I'm going to erase this for now. Okay, I'm going to erase this. Now, think of SOHCAHTOA. SOHCAHTOA. Or if you just already have these memorized, think of that. So, what if we are asked find the cosecant of theta? Well, cosecant we can say is the opposite of sine. So instead of opposite over hypotenuse, it's hypotenuse over opposite. So in this case, cosecant of theta, cosecant of theta will be represented as c over a, right? Hypotenuse over opposite. Now, in terms of remembering, remember, the opposite of, or like you cannot say inverse of sine if you're wondering, like, oh, could I have just said inverse? No, that is for a different video. Inverse of sine, the inverse of sine and cosecant are not the same things, etc. Same with like inverse of cosine, inverse of tan, not the same thing as their opposites. So now, speaking of, what if you were asked secant of theta? Well, we know that, right? The right? Adjacent over hypotenuse. Instead, it's hypotenuse over adjacent. And in this case, if we want to evaluate secant, if you want to just evaluate secant, right? Secant of theta, you can, since you know it's hypotenuse over adjacent, right? Hypotenuse is c, right? And adjacent is b. So c over b. So now going to tan here, there's something called cot or cotangent, that is, remember, we know that tan is opposite over adjacent, or TOA, right? Opposite over adjacent. In this case, it's just adjacent over opposite. So in this case, cotangent of theta remember, since it's adjacent over opposite, adjacent to theta, remember, is b over opposite is, right, opposite of theta, a. So hopefully you get this. If you get the SOHCAHTOA, you will get this. And in terms of memorizing this, it sort of goes either way here. You can sort of think, right? We have sine. Let me use a different ink here. We have like sine, right? Is the inverse, is the, sorry, not, should not say inverse, opposite of sine, or the reciprocal of sine. Remember, reciprocal as in we switch the numerator and denominator. Remember, sine of theta was a over c, but cosecant of theta was c over a. So sine, you could think like, oh, like what seems like, for example, if you have cosine and cosecant, do they seem like sort of different? Like, no, those, they seem like they sort of sound similar. Cosine, cosecant. Whereas like sine and cosecant sound sort of like, like, oh, this seems like this would be the opposite of this, or the reciprocal of this is cosecant. Or cosine, right? Secant seems like it would, whereas like sine and secant, they seem like like they don't seem like they're opposite. You know what I'm saying? So, as in cosine and secant, they sound sort of opposite as well. And in terms of like tan, that one's an easy one. Like cotangent, you're like cot, tan, cot, t, hint, t. And if you know the full form cotangent and tangent, you're like, oh yeah, those match. So that's sort of an elimination. You will probably be fine with that. So in terms of sine, just remember cosecant, right? Well, they sound sort of opposite, right? They sound sort of opposite, or sort of contradict. They contradict each other. Sort of. It sounds like that, at least when you hear the word cosecant and sine. Whereas if you see cosine and cosecant, they, I don't know, just sound similar. That's how I just memorized it. In terms of like the naming and stuff. Okay, I'm just trying to. Did not mean to do that. Okay, so that's it in terms of the right triangle trigonometry that you need to know as of right now. I'm gonna just give some practice problems now. We're just gonna do some examples. So make sure you have all of the stuff even before the video. You can rewind, just write it in your notebook. You'll be good to go then. So let's just do some examples, some quick examples. Don't worry, it's not gonna take all day. I like the explanations. So example. Okay, we are given a triangle, and this is like a common problem, like a common sort of thing. Like, okay, so we're given it's like a right triangle, and we're given an unknown angle. And actually, what I'm going to do is put theta here. Now you're probably wondering, is the opposite side still here, like when theta was there? No, because you still got to think here, using logic. What is opposite to theta? Well, we draw an arrow. We know that this is opposite, sort of. You can even shift the position of the triangle. Like, you can put it into... Oops, what did I just do? You can even like shift the position of the triangle, and like put it here if you don't like it. or if you don't just you're not used to seeing it this way, you can just do it here. But in terms of the problem, I'm just going to leave the diagram how it is, or the triangle that is given to us how it is. And the problem is going to ask us evaluate, or let me first, we have some side here. I'm going to give some value. Right, so we have a triangle. Let's just say this is 12, or let's just say this is 3 and 5, or let's use green here. This is 3, this is 5. Okay, classic problem, and the problem is asking us to evaluate, or just use all three, or just apply all three, apply all 6. Why did I put all caps there? Apply all 6 trig functions, or like ratios, perhaps ratios, like slash functions, whatever you want to call it. So remember, just gonna write this at the top here. Remember, SOHCAHTOA, CAHTOA. I like to say it like SOHCAHTOA. Just remember, SOHCAHTOA can sound like this sometimes. SOHCAHTOA, but no. That's why I like to emphasize this. SOHCAHTOA. Just remember the adjacent part. Okay. Anyways, let's find sine of theta. Well, we have sine of theta here. That's sort of an easy one, right? So, or is it actually sine of theta? So we know that sine is opposite over hypotenuse, but opposite side is what now? So that's what we have to figure out, right? Because when we draw that arrow, the side is not given to us. But luckily, we have something called the Pythagorean theorem, which hopefully you remember, a squared plus b squared equals to c squared. Now, in this case, in specific, right, we can apply the theorem. I'm going to apply the theorem here, but just something to remember. If you know geometry, this will be 4. Why? Because this is a Pythagorean triple. But I'm going to apply the formula because maybe some of you guys don't even know what a Pythagorean triple is, and this video is not about that. So we can say that this is like our A, this is our B, this is our C. We're trying to solve for B, of course. So we get 3 squared plus B squared equals to 5 squared. Then we get 9 plus b squared equals to 25. We get b squared equals to 16. We get b equals to 4. Remember, no plus or minus 4 because we are dealing with the arithmetic square root. So, b will equal 4, meaning that we can rewrite this as 4 here. Now, just remember, Pythagorean theorem, gotta know it in trig, man. You gotta know it. You gotta know Pythagorean theorem, especially in right triangle trigonometry. That's why I specifically brought up this problem. Of course, Pythagorean triple could have been applied here, like 3 if A is 3, B is 4, or if A is 3 and C is 5. I don't really know that B is going to be 4. But that's not the priority now. You are fine. Just remember the Pythagorean theorem, of course, which most of you do. Which usually, I mean, even people who don't know math just know the Pythagorean theorem. Because they're like, oh, a squared plus b squared equals to c squared. I'm just gonna, since my erase box thing is not working, I am going to, okay, now I can try to use it now. Okay, sort of. It's working. A little bit. Okay, so we just proved it, that it was 4. B equals to 4, so I'm just going to put 4 here. Okay, so now sine of theta. We know that's so opposite over hypotenuse, 4 over 5. Why? Opposite of theta, 4. Opposite of the 90-degree angle is 5. So 4 over 5 it is. Just remember, in future cases where like it'll give you a fraction like, I don't know, let's think here, like 5 over 10, something like that, always simplify it to 1/2, or just simplify the fraction. Don't keep it unsimplified, because that's where you could probably lose some points. Just remember, do that. Now, cosine of theta. Cosine of theta. What is cosine of theta? Hopefully you know this. Cosine of theta. Remember, ka. Adjacent over hypotenuse. What is next to theta? 3 is next to theta, right? So adjacent, 3 over hypotenuse. Hypotenuse is opposite the 90-degree angle, which is 5. Yay. 3, remember, adjacent over hypotenuse, 5. Now tan. Tan's the one without the, remember, toa. Opposite over adjacent. What is opposite to theta? 4. What is adjacent to theta? 3. 4 over 3, right? Opposite, 4. Adjacent, 3. 4 over 3 is tan of theta. Now, let's find, since it's all 6 trig ratios / functions, now you need to apply the other ones. So remember what contradicts sine, sort of cosecant. Sort of think of it like it sounds sort of the opposite of sine, right? So cosecant. In that case, remember, just switch the numerator and the denominator. That's 5 over 4. Remember, because it's hypotenuse over opposite, right? This is secant of theta. That's just, remember, switch the numerator and denominator. We get 5 over 3. Cotangent, or cot of theta, that's just 3 over 4. You see it now? You see it. Alright, so this is the answer to our problem. We figured it out, guys. Great. So this problem basically, this pretty much covers everything we learned in today's lesson. If you have any questions, just, reach out in the comments. And I'll see you on the next one. Alright? Have a good one.